California, the Golden State, home to Hollywood glamour and Silicon Valley innovation, sits astride a geological time bomb, the San Andreas Fault. This massive fracture in the Earth's crust, stretching over 800 miles, is a constant reminder of the immense power beneath our feet. The fault, where two tectonic plates grind against each other, is capable of unleashing earthquakes of unimaginable magnitude. The question is not if, but when, the next big one will strike. Imagine the Earth's crust as a giant jigsaw puzzle, with each piece representing a tectonic plate. The San Andreas Fault marks the boundary between the Pacific Plate and the North American Plate. This constant grinding and pressure buildup along the fault line causes earthquakes. The San Andreas Fault is a stark reminder of the dynamic nature of our planet. The San Andreas Fault is a complex system of fractures slicing through California. It stretches from the Salton Sea in the south to Cape Mendocino in the north. This transform fault is where plates slide horizontally past each other. As you push one brick past the other, friction builds up until they slip, releasing energy. This is what happens along the San Andreas Fault. When stress exceeds rock strength, they rupture, releasing seismic waves, an earthquake. The fault is divided into 3 segments, each with unique characteristics and seismic potential. The San Andreas Fault has a long and violent history, a history etched in the annals of California's past. Over millions of years, countless earthquakes have occurred along this fault, shaping the landscape and leaving their mark on human civilization. Scientists study these past earthquakes to understand the fault's behavior and to assess the likelihood of future events. One way scientists study past earthquakes is by examining geological formations along the fault. By analyzing the displacement of rocks and sediments, they can estimate the magnitude and timing of past earthquakes. Another method is through paleoseismology, which involves digging trenches across the fault to study the layers of sediment deposited over thousands of years. By dating the layers and identifying evidence of past earthquakes, such as deformed or liquefied sediments, scientists can reconstruct the fault's seismic history. The San Andreas Fault's history is a reminder that earthquakes are not random events, but part of a recurring cycle. By understanding this cycle and the factors that influence earthquake occurrence, we can better prepare for the inevitable. The 1906 San Francisco earthquake stands as a stark reminder of the San Andreas Fault's destructive potential. On the morning of April 18, 1906 at 5:12 a.m., the earth beneath San Francisco lurched violently. The earthquake, estimated at a magnitude of 7.9, ripped open the San Andreas Fault for nearly 300 miles from San Juan Bautista to Cape Mendocino. The shaking lasted less than a minute, but its impact was catastrophic. Buildings crumbled, streets buckled, and fires erupted throughout the city. The earthquake and subsequent fires destroyed over 80% of San Francisco, leaving more than 200,000 people homeless. It was the deadliest earthquake in U.S. history, with an estimated 3,000 lives lost. The 1906 earthquake was a turning point in the scientific understanding of earthquakes. It spurred the development of seismology as a science and led to the development of building codes and emergency preparedness measures. The lessons learned from this disaster continue to shape our understanding of earthquake hazards and inform our efforts to mitigate their impact. NASA's watchful eye, unveiling the fault's secrets. In recent years, NASA has played a crucial role in advancing our understanding of the San Andreas Fault. Using cutting-edge technology such as radar interferometry and GPS measurements, NASA scientists have been able to map the fault's movements with unprecedented precision. These observations provide valuable insights into the fault's behavior and help scientists refine their earthquake forecasts. One of NASA's key findings is the discovery of creeping segments along the San Andreas Fault. These segments, unlike the locked sections that rupture in large earthquakes, are characterized by slow, continuous movement. This creeping motion helps to relieve some of the stress along the fault, but it also raises questions about how it might influence the timing and magnitude of future earthquakes. NASA's research on the San Andreas Fault highlights the importance of continuous monitoring and scientific investigation. By combining ground-based observations with satellite data, scientists can gain a more comprehensive understanding of the fault's complexities and improve our ability to anticipate and prepare for future earthquakes. The looming threat, a matter of when, not if. The San Andreas Fault remains a constant threat to California and beyond. Scientists agree that a major earthquake along this fault is not a matter of if, but when. The question is not whether an earthquake will occur, but rather when it will occur and how prepared we will be when it does. The U.S. Geological Survey estimates that there is a 72% probability of at least one earthquake with a magnitude of 6.7 or greater striking the San Francisco Bay region in the next 30 years. The probability of a magnitude 7.5 or greater earthquake in the same region is estimated to be 33%. These probabilities, while sobering, underscore the urgent need for preparedness and mitigation efforts. Preparing for the inevitable, building resilience. Given the inevitability of a major earthquake along the San Andreas Fault, preparedness is paramount. Building codes and infrastructure improvements are crucial to minimize damage and save lives. Retrofitting older buildings, strengthening bridges and overpasses, and ensuring the integrity of critical infrastructure such as hospitals and power grids are essential steps in mitigating the impact of a major earthquake. In addition to structural improvements, individual preparedness is equally vital. Having a family emergency plan, securing heavy objects in homes and workplaces, and maintaining an emergency kit with essential supplies can make a significant difference in the event of an earthquake. Public awareness. Knowledge is power. Public awareness is crucial to fostering a culture of earthquake preparedness. Educating the public about earthquake hazards, promoting safety measures, and encouraging individual and community-level preparedness are essential components of building a resilient society. Schools, community centers, and local organizations play a vital role in disseminating information and promoting earthquake awareness. Holding earthquake drills, providing educational materials, and engaging in public outreach programs can empower individuals and communities to take proactive steps to prepare for and respond to earthquakes. The San Andreas Fault, a stark reminder. The San Andreas Fault stands as a stark reminder of the powerful forces that shape our planet and the importance of preparedness in the face of natural hazards. By understanding the fault's history, its potential for destruction, and the importance of mitigation and preparedness, we can strive to minimize the impact of future earthquakes and build a safer, more resilient California. The San Andreas Fault is not just a geological feature, it is a call to action. It is a reminder that we live in a dynamic and ever-changing world, a world where preparedness is not an option, but a necessity. By embracing a culture of preparedness, we can transform fear into action and build a future where we can coexist with the forces that shape our planet.